Started. Inductive effect. The polarization of sigma bonds due to the difference in electronegativity is called inductive effect. Consider this example. Chlorine is more electronegative than carbon. So the bonded pair of electrons are attracted towards chlorine. So chlorine gets a partial negative charge and this carbon gets a partial positive charge. But this polarization does not end here. And because of this bond is also polarized and the effect uh, continues to pass along the sigma chain, carbon chain. But this effect diminishes after 3 or 4 carbons. This is called inductive effect. So the polarization of sigma bonds due to the difference in electronegativity is called inductive effect. This effect is very important to explain the differences in reactivity, stability, acidic and basic nature between the compounds that have the same functional group. We'll see an example. Strength of an acid depends upon the stability of its conjugate base. More stable the conjugate base, stronger the acid. Let's explain the acidic nature of halo acids using inductive effect. This is the order of acidic nature for the haloacids. Haloacetic acids, more precisely, haloacetic acids. So fluoroacetic acid is more acidic than chloroacetic acid, which in turn is more acidic than bromoacetic acid, which in turn is more acidic than acetic acid itself. What is the reason behind this trend? The conjugate base that is formed from the acetic acid, which is acetate, a negatively charged species, can be stabilized by an electron withdrawing group like fluorine. The acetic acid lacks that group, so here you have extra stability of the conjugate base by the electron withdrawing effect of the fluorine. That thing is not there in the acetic acid. So acetic acid is the weakest acetic acid here. Fluoroacetic acid is the strongest acetic acid here. So fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine. And that explains why fluoroacetic acid is more acidic than chloroacetic acid, which in turn is more acidic than bromoacetic acid. So what is the main objective of this lecture, this video? To explain the inductive effect and how it is important in explaining the differences in properties that exist between the same functional group. Here, the difference in property that exists between the carboxylic acid compounds. Thank you.